Well, thank you so much for joining. I want to talk about design patterns in the light of Lambda expressions. So I want to talk about patterns. We as programmers are very fascinated about patterns, right? Anyone who has used design patterns recently? Yeah, that's everybody, right? In fact, I know some of us had breakfast with design patterns this morning, right? We love design patterns. But here's the problem. Imagine you keep talking about how wonderful grandma's pie is. You have said about this to all your friends, and your friends tell you, if grandma makes such a wonderful pie, you should make it for us. So you get nervous. You call grandma and say, Grandma, I'm in trouble. I've been talking about your pie to all my friends, and they asked me to make it. Can you give me the recipe? And grandma says, oh, it's really simple. Take some flour, take some sugar, put them together. Whoa, slow down. Give me the recipe now, I'm going to write it down. And grandma says, put some flour, put some sugar. You say, how much sugar? Oh, 2. Wait, is it teaspoons or tablespoons? You write all these details meticulously, and you go over this, and then you ask Grandma, what are the best practices? And when you finish making the pie on that Saturday morning using the recipe, how did that turn out to be? Yeah, a disaster, wasn't it? And the last time I tried something like that, I lost the spoon with it as well. And then you go meet Grandma the next week and say, Grandma, your recipe was a disaster. It didn't work. And Grandma says, why don't we talk about this while we make the pie? And you're watching Grandma make the pie, and what is she doing? She takes 2 tablespoons of sugar, measures it accurately, and puts it right? No. As she's having a good time talking to you, she takes some sugar, tosses it in, and says that. And you say, whoa, what was that? She says, sugar. And you said, how much did you put? And she says, enough. And that's when you realize Grandma doesn't use the recipe she gave you. Where am I going with this? Well, one of the best books ever written in the world is the book on design patterns, known as favorably the Gang of 4 book. The 4 people who wrote that book, I would argue, are the grandparents of our industry. And the worst thing those 4 people did in their life is to write the damn book. Because everybody said, we can do it. And the next thing you see is a disaster in the making. What I'm claiming here is design patterns are phenomenally great communication tool. They are not as much a great design tool, in my opinion. I've seen so many developers use patterns and complicate the design overly and unnecessarily. In fact, I would recommend this. When you wake up in the morning, if the first thought on your mind is, I wonder what design pattern I can use today, I recommend you call the boss and say, you're feeling very sick, and don't bother going to work today. Now that I inspired you about design patterns, let's talk about some design patterns. So design patterns are interesting tools as a communication tool, like I mentioned, and I really like design patterns when I can use them to communicate, to say, what am I doing? And as the language evolves, some design patterns we are used to already become a lot simpler. Some design patterns we never used before, most likely, or now we are able to use them as well, and that's really the fun part. I want to talk about a few different patterns where we can use lambdas as design tools. Now, one of the really interesting things about lambdas is that lambda expressions really give us the ability to pass functions around. And so as a result, in addition to doing object composition, we can also do functional composition as well. Let's explore those ideas with 3 different examples here and discuss how they could be effective. The first one I want to start with is a strategy pattern. We all have used a strategy pattern, isn't it? Strategy pattern is really effective in saying, here is an algorithm, and most of what I want to do is captured here, but I want a small variation to the algorithm, which is the strategy we want to bring in. But how did we do the strategy back in the time in Java or most of the languages we were familiar with? And the reason is, because we had classes and objects, we first created an interface. Then we created a bunch of classes. Then we created factories to create these classes. And along the way, we forgot why we are doing all of this. And then, of course, we have 2 corporate meetings to talk about this design. And that is complexity, isn't it? But why did we do it? And this really goes back to the ideology that was once prevalent in Java, and that is everything is objects. But a strategy fundamentally is a function. And all you want to do is just to pass this function around. But what did we do? Oh, we said, no, we cannot treat functions as first-class citizens. So we treated functions like they are kindergarten children. The little function says, excuse me, can I go to the neighborhood park, please? No, sweetie, you cannot go alone. Let me wrap you in an object and send you with an adult. So essentially, we couldn't really pass functions around, and now it's as if that little kid grew up and starts driving around as an adult, and now we are like, it's okay, we can have functions that can move around. Functions are first-class citizens. We can benefit from that idea very clearly. But let's take an example. Let's say you've been talking about this day when you're going to meet your friends, you're excited, you've been a long time waiting for them, your mind is in this party you're going to have tonight, but your colleague wants you to write a piece of code. They ask you to write the code that is going to say total values, where I'm going to pass some numbers in here. And what are the numbers? Let's say numbers is equal to, let's say list of numbers 1 to 10, let's say, in this particular case. So I want to bring these numbers together and total values. How would I write it? So I say public static, let's say in this case int, we'll call it as total values. Let's take an integer list of numbers or values, if you will. And this is not a really hard thing to write. We could say, for example, a result is equal to 0. I want to return the result in the very end of this. But here I can say for int element, or element is going to be coming from the values, and we can simply say result plus equal to element. So this becomes a really easy way to write the code to total all the values. A result of 55, not a big deal, right? And when you finish doing this, you are really interested in this party you want to go to, remember? And you're about to leave when your colleague says, I need one more function from you. And you're like, really? What do you want? I want functions that total all the even numbers in this collection. And you say, really? What you want is this, even numbers. And they say, yes, I want that. And you're not really interested in writing this right now because you really want to go to the party. But your colleague wants it. And you're thinking, what do I do? And you realize the code is a lot similar to what you already have. And then you think about this and say, oh, come on. If copy and paste is so bad, why would they create it? Right? In fact, it's such a wonderful feature. There's a shortcut key, Control-C, Control-V. How cool that is, right? So you realize, I can get this done very quickly. I can go on. So you simply gently copy it. And then you paste it. And you simply say, here you go. That's my code. And you modify this to a total even values. And then you simply say, if the value mod 2 is equal to 0, then total, not otherwise. And guess what? It works. It's not that bad after all, isn't it? Push it to production. Well, a few minutes goes by, and your colleague comes to you one more time and says, even numbers great, but I want you to compute total of odd values. And now you think about this and say, oh my goodness. The code I want is, again, very similar to it. But you know deep in your mind, copying and pasting the code a third time is an act of criminal negligence. But nobody is watching, and it's a Friday. Well, if you go proceed with that, what's going to happen? Then you finish it, you leave for this party, you're on the way, and on the way, guilt kicks in. And you said, that's not what I was hired to do. Ew, that feels really, really bad. And you immediately go into a nearest coffee shop and you're refactoring code. And when your close friends who are around there come and ask you what you're doing, and before you could close your laptop, they take a look at your code and they get to know your dark side. And they never return your phone calls anymore. They don't respond to your SMS. Who would want to hang out with people who do copy and pasting for a living after all? So this really turns dark very quickly, isn't it? Let's give it a try. Let's do something different. Pretend this never happened. Roll it back. So we have this code, and your colleague says, hey, I want this function to total all the even numbers. Time for a little refactoring. So you go back to the original function we had, and we now say, here you go. Let's bring in a function right here. And then, of course, I'm going to say, bring in a predicate in here as a second argument. So I say predicate, and I'm going to say integer, and this is going to be the selector I want to bring in. And I can say in here, if the selector.test on the element is interesting enough to accept, then total, not otherwise. And a little refactoring later, we can say, given an element, simply return a true, and we can simply get that working. Now that we refactored it, we can now say, given an element, if the element mod 2 is equal to 0, then of course, go ahead and do that, or if it is not equal to 0, and now we have the functions really done. So in other words, we can pass that as a strategy by simply passing lambda expressions. So as it turns out, lambdas can simply become strategies and what I would like to call as lightweight strategies. And they become really so easy to pass them around. They are incredibly simple and easy to work with. And so we can just get the work done rather than talking about it. That's one of the biggest benefits we get out of that. Well, moving a little further, we can also use this to build a nice decorator pattern. But before I talk about decorators, I wanted to remind about the most infamous example of decorators. Do you remember what that is? Buffered input stream is equal to new buffered input stream parenthesis, new data input stream parenthesis, new, remember that? And you looked at it and said, oh my goodness, what's going on here? And then you doubted yourselves, and you looked up the dictionary. Maybe the word decoration means to take things and make them ugly. And we looked at this and said, oh, no, that's not for me to use. Well, decorator pattern is this one scary thing we read about, don't want to touch it. But it doesn't have to be that way. We can make use of decorators really nicely. But here is one interesting, charming factor, though, we can benefit from. And that is, if I take a function, let's say integer, and in this case, I'd say increment is equal to, and this is going to take an integer and return an integer, let's say in this case. I can take this function here, and I can then say, given a value, return a value plus 1. I can also have one more, we'll call it double it. And I can take this value, and I can double this value as well. But here's the beautiful part about this. You can create a function, increment, and so you can say over here, let's say a public, let's say static void, a print, which takes a function, which takes an integer, let's say, and returns an integer, and I'll call it as func. And within this function, I'm going to simply say output, let's say func.apply, and send a value of 5, let's say. So I can call this function, for instance, with a print and send an increment. I'm incrementing 5 after all, as you can see in this case. Or I can also go ahead and call a print, but I can call it double it. And 5 times 2 is 10, as you can see. But what if I want to increment and double it? Now, obviously, I cannot send 2 functions to this function. It only wants 1. But here's the beauty. You can take the increment and you can say and then, and you can combine it with the double it function. And when you do, this gives a nice way to combine functions together. So this becomes a nice functional composition. So you can take 2 functions, combine them, and create a bigger function, just like you can take 2 objects, combine them, and create a bigger object. We are familiar with object aggregation. We can do function aggregation. We call it functional composition. So in this case, we can leverage this idea really nicely. Let's take a look at an example of how we can benefit from this. So imagine I have a function right here. We'll call it as a print function, if you will. And the print function takes a camera, let's say, as an argument. And here comes a camera. And what I want to do in this function is simply say output camera.snap, and I'm going to say new color, let's say 125, 125, and 125. So I've got this color I want to snap in this particular camera. Now, obviously, where is all this coming from? We'll say this is awt.color, but let's create a class called camera right there. So the camera has a function in this case called a snap. So it takes a color, as you can imagine, and it returns a color as an output. For now, simply return the input given. So if I were to go back and call this one and call print and say new camera, it's garbage in, garbage out. The same color needs to come out. You see the color being printed out right there. But I have a mind that is always thinking about programming. I've got a background thread where I keep thinking about programming and code all the time. So when I'm out in the wild, when I'm looking at a tourist spot, I love hiking mountains of Colorado. But when I go there, I will see people with really fancy cameras. And I have to tell you, every time I look at a camera, my mind has to think about decorator pattern. And the reason is they have this fancy camera, but they want to take something at a distance, or they want to take in a poor light condition. What do? They reach into their bag, and they take a little lens, and they remove their lens and put another lens, or pipe these lenses together. And I'm like, whoa, that's a Decorator pattern right there. Because all they are doing is they take this camera, and they can keep adding these filters. The word filter in this context is a filter as a lens, not a filter as the functional programming filter. So we can actually benefit from that right here. So what we can do in here is, maybe I want to add a filter to this. So what I will do is to create a function, if you will, as a filter. So let's bring that in. So I say function, and this is going to take a color in this case, and return a color, and I'll call it filter. Now in this case, I can say filter.apply, and pass the input out to it, as you can see in here. So then, what in the world is this filter? So I can say a public camera as a constructor, if you will, and a function that takes a color and returns a color, but I'm going to say in here, it's a var arg, I'll call it filters, if you will. So this filters, of course, is a collection of these filters you can pass in, and because it's a var arg, you can send an empty object as well. So to begin with, I can say filter is equal to, given an input, I want to simply return an output, right? That's a trivial filter. Let's start with these baby steps, if you will. So the code is still working after the change. But I want to then come here and say, here is a camera. It's going to take as an argument, given a color, I want to take the color and brighten it. I'll say brighter. Or alternatively, rather than doing that, why not simply say a color? And in this case, I can simply use a method reference and pass the brighter color to it as well, like so. Now, obviously, it didn't do the job yet because we haven't implemented the code yet. But notice what I can do now. I can go back here and say var filter, and that comes from the filters, if you will. I can then say filter is equal to the filter and then, and I can add a filter to it like so. And we can combine them into a decoration. I can see the bright color is brighter, as you can see. Or I can go back to this and make the color darker here as well, and you can see the color is less than 125. But you know where I'm going with this. We can now start combining this, and I bring in a brighter and a darker into it as a mix. And now we can start putting decorators together. Maybe one little more refactoring will really help us over here. What I can do here is to turn this into a functional style as well. Now, if I were to turn this into a functional style, anyone wants to take a guess what function we would probably use to turn this collection of filters into one filter? Bingo, thank you, reduce function. You nailed it, awesome. So we can use the reduce function. So let's try to use the reduce function instead. So we can get rid of all of that. Let's bring in the stream in here. And so what I can do is, in this constructor, I can say a filter is equal to stream of filters dot reduce, as you suggested. What's the first one? Given an input, just give me that as an output. What's the second one? This is going to be the combined filter, comma, a filter. So you get both of those. And what you can do is you can then say combined and then a filter, and you can use the reduce function. That works. But some of you may look at this and say, I'm not satisfied yet. I want this to be even more concise, isn't it? So let's give it a try. How do you make this more concise? Well, quick question. Some of us probably stayed in the math class. And remember in the math class, they tried to teach us something, right? They said, if you take an x and add a 0 to it, you get back an x. If you take a y and multiply 1 to it, you get back on y. And they said these functions have a name for them. Anyone remembers that? Nobody stayed back in the math school. Identity function, thank you. You made me worry for a minute. I thought I was the only one who was cutting classes. Okay, so identity function, absolutely. Identity functions can be really useful. And guess what we are doing? Give me an input, I'll give you that as an output, right? So this simply becomes an identity function. So this becomes a function, function dot identity. So that becomes the identity function, great. But then you say, all right, that works, but why not simply go a little further with this? I'll just put it here so it's easier to read. And we can then say, hey, here, that's just a lambda that calls that function, isn't it? So get rid of all of that from there, and we can simply say that becomes a function and then. So that becomes a nice little function method reference. So we can refactor that code as well, nice, elegantly, as you can see. But let's think about this for a minute, if you will. What are we doing in here? If you look at this particular example, this is a decorator pattern using lambdas. But what is a decorator pattern really? A decorator pattern decorates an object. So you have a core object. You know, I often usually have a very casual clothing. I don't really wear fancy things. That's just me. But on the other hand, if a good friend invites me to come for a wedding, I'm not going to show up in my shorts. That's not respectful for a friend. And so I might put on some really nice pair of clothes on me. Maybe even my wife can convince me to put on a tie that day. That would be a very unusual decoration of me. But I don't say, oh, that party, I will send somebody else for it, right? It's still me who's going to go to it, but I'll decorate. I'll dress up and dress down based on where I'm going. That's a decoration. So in other words, you take a core of an object and you add layers of functionality, features, flavors to it. That's a decorator pattern. So here you took the basic camera as an example and you added these filters to it as a decorator. So this becomes a nice idea we can use in several places. I have a packet of data coming in. I want to perform decryption or encryption of the data. I want to mask some data. I want to transform some data. I can decide which of those I want to put in which order I want to put them. I can decide that in my code. This becomes a lot easier. That's the power of this decoration. So you can use this idea to create these decorators as functions where they get an input and return an output. And then you can have this library of these functions around. And then you give the users of your code the flexibility to put them in any combination you want them to put in. And that becomes a nice, effective way to use the decorator pattern. Let's move on a little bit further to the next piece of idea here that we can use, and that is one of my favorite patterns, which is called the execute around method pattern. The execute around method pattern is a pattern that's been around in functional programming languages for a long time, or languages that support Lambda expressions. With more languages providing Lambda expressions today, we can benefit from this particular pattern really nicely. Now, what problem are we really trying to solve with the execute around method pattern? Notice the word execute around method. So you have something, but you want to execute something around it, a pre-op and a post-op. A lot of things we do fits into that model. For example, you can write a piece of code where you want to perform maybe an initialization of something. You want to execute some operation, and then you want to perform a logging or a committing at the very end. And I remember one project I was working on as a consultant, in fact, here in the Netherlands a few years ago. And we were developing an application where about 2 or 3 weeks into the development, what I noticed was the programmers followed an interesting pattern. They would write a service, and when they wanted to write a new service, they would start with the ritual of copying and pasting the service code over. And then they would take the middle of it and delete it. And they would start writing the code. Apparently, that's called template-driven development. Well, not a good idea, right? And when I noticed this, I said, wait a minute, what are we doing? Oh, you know what? The top part is the same for all the services. The bottom part is the same for all the services. So we just copy and paste it. Well, that's not going to be fun because we all know if we duplicate the code like that, it becomes expensive to modify in the later stages. So what we did is to apply this pattern where we said run in transaction and we write the middle part alone. But the run in transaction function, before it calls the middle part, will call the initialization part, then invoke the middle part. When the middle part is done, it would come and check on the status of the transaction and take care of the rest of the action. So this really removed the duplication in the code for us. I also see this a lot in applications where, for example, you want to open a file, but you don't want to close a file because it's easy to forget to close a file. So you just open the file, use it, and you leave, and the cleanup happens automatically. Now, this is a nice idea, but one of the things I also like to do is to really make the applications easy to use. When an application is easy to use, when a design is really good, it becomes very easy for us to make fewer mistakes. And I really have to tell you that I truly pause and admire good design when I see it. I truly appreciate good design because somebody took the time to make my life easy by putting an extra effort on it. But I'll give you one example of it I would never forget. And maybe this was a lack of my judgment, but I was working through the night. And in the morning, I said to myself, things are stable, things seem to be working. I'm going to go home, take a shower, come back to work. And I started driving home from work in the morning. And I could barely keep my eyes open. I was absolutely sleepy. And you could say, Venkat, that's not safe to drive. I completely agree. But on the way, I found that I don't have enough gas in my car. So I went to the gas station, and I put the card, and I take the nozzle, and I'm trying to put it into the gas tank. It just wouldn't fit. And I'm thinking, Venkat, you're tired. You don't even know how to fill gas anymore. And I said, let me wake up, and I'm looking through it, and it just wouldn't go in. And that's when I figured out these people are amazing. They designed the nozzle for petrol different from the nozzle for diesel. And I was trying to fill diesel into my car, which was taking petrol, and it wouldn't work. And I was ever so thankful for that. I mentioned this about 2 months ago in a group like this, and one guy raised the hand, and I said, yes, and he said, I really wish my sister stopped at that point. I said, well, what do you mean? And he said, well, my sister is the determined one. She went and got a funnel. It did not go well. $3,000 later. But I appreciate really good design. So if you are able to really design in a way, I don't have to think. Isn't that wonderful? Let's think about this idea, if you will. So I'm going to say in here, let's create a class called resource. And the class resource is going to say a public, let's say, resource. And in this case, I'm going to say output, let's say creating external resource. So this is going to use some stuff outside, maybe external web service, a microservice, a database, whatever that it could be using. Then I say public, let's say resource op1, and this is going to simply say output, let's say op1, and it's simply going to say return this and return that particular value in here, right? That's all it's doing. Then similarly, we'll write one more function for our purpose, keep it really trivial here. And then I say public void finalize. And the finalize method says output cleaning up external. We'll say release, how about that? Release external resource, right? So far, so good, isn't it? So we wrote this code, and what are we going to do? I'm going to say resource is equal to new resource. And resource.op1, and I want to then call resource.op2, right? We'll call these two functions, as you can see. Run the code, what does it do? It created the resource, printed op1, and of course, copy and paste printed op2 as well. So that really did the job, but what about releasing the resource? Well, the releasing the resource did not happen, isn't it? Why not? The finalize was not called. Why was the finalize not called? Because a garbage collector said, I don't need to run. Why not? Because a garbage collector in Java is like the garbage collector in my neighborhood. Just because I put out the garbage doesn't mean anything to them. I call them and say, excuse me, I put the garbage out. Well, thanks for letting us know. And 2 days later, it's still there. It's like, dude, why don't you take it? They're like, we got better things to do than collect your garbage. When there's enough garbage, we'll come and collect it. Otherwise, be quiet. So the finalize never called because you had a lot of memory, and the garbage collector said, I don't need to be calling it, right? Well, but what happened to the external resource in the meantime? You haven't released it, and you're going to have problems with it. I had a client like this. They called me and said, could you come and refactor the code for us? And while you're doing it, could you help us to fix a bug we have been having in production for a while? And I asked the boss, what's a bug? He said, I don't know. Go ask the programmers. And I went to the programmer and said, hey, your boss said there's a bug. Can you tell me what it is? And nobody would tell me what the bug is. How do you fix a bug that you don't know what it is? And finally, I found one developer who said, I can tell you what it is. I said, that's cool. What is the bug? And he said, the code works fine most of the time. I said, that's awesome. Can you tell me when it doesn't work? Oh, of course. It doesn't work between 7:30 and 9 in the morning. I said, really? Yep, 7:30 to 9 in the morning. Every day. He said, no, only Monday through Friday. It works fine on Saturday and Sunday. I'm like, that was very helpful, thank you. Well, as it turned out, as I was looking through the code, I found what the problem was. This application was running in a portal. The company has thousands of employees. Guess what's happening between 7:15 and 9 in the morning? People come to work. They log in. Whether they care about the app or not, they're using it. Saturday, Sunday, not many people come to work. And it turns out in the constructor, they were calling a database connection. And in the finalize method, they were releasing it. And since there was a lot of memory, the finalize never ran, and the objects were not released, and the app was choking up. So what do you do to fix it? Well, you can look at this code and say, hey, that's really bad. Maybe we can try something else. How about system.gc? If you ever want to write a comment for code, this is a good place to write it. You can call it hope. Because the GC is like, really? Like, I'm going to come and do it for you, right? No. So that doesn't work. So what do I do? Hey, here's an idea. Why don't we take this out and call it as close right there, right? So we'll call this a close method. So when I call this a close method, I can say resource.close. And you run the code, and you can see that it's doing the job. And that's exactly what I did on that particular project. I just told them, rename your finalist to close, call close, let's see what happens. And we did that. And one of the guys said, oh my gosh, it works. I said, how do you know it works? He said, I'm keeping track of the database connections. And it's going down all of a sudden. Well, the fun part was that afternoon, because the boss came around, and one of the developers said, hey, you know the problem we've been having? Like, well, we fixed it. And Venkat gave us what to do. Really? What did he do? Oh, he wrote this one line called close. And the boss said, what else did he do? That's it. He wrote this one line called close. And then there was a silence, and then he asked them, if you only wrote one line, do we still need to pay him? But as it turns out, this is not a good solution, right? Why? Because what if there was an exception in between in the code? Oops. So now we put a try block around here, isn't it? So then we say a try, and then we say here comes a finally block, because if there's an exception, you want to handle it. If there's no exception, you want to handle it. So you wrap it into a finally block. Now when you do this, hey, that's good news, it's working. But what's the problem? Is it quite possible we may forget to put the try block? Very common, isn't it? So you forget to put the try, you forget to call the close, and you're back to square one. We keep debugging this over and over and over. Second problem, the code is verbose. You have to put a try, you got to put a finally. What a ceremony, isn't it? You could say, can this be simpler? Well, in Java 9, they deprecated the finalize method. So you no longer can call, shouldn't call, use finalize method. Why did they deprecate finalize? They deprecated finalize because it is no guarantee to be called. That's a terrible way to handle resources. But that was in Java 9. But in Java 7, they introduced an interesting idea. And the idea was called ARM, which stands for Automatic Resource Management. And automatic resource management says, we will automatically manage the resource for you. Sounds like a great idea, isn't it? So you can say try like so, and then you can say in here, resource.open, resource.op1 and resource.op2. You don't have to call close in this case. That's really nice because it's less ceremony, less work. But for this, you have to say implements in here, auto-closable. So by putting auto-closable, you can run the code, And you can see what happened in this case. The close was called automatically. Seems like an interesting idea, isn't it? This thing called automatic resource management. And this is try with resources. So you say, problem solved, right? Why don't we be happy about it? Well, looks interesting, no doubt about it, but assume, as I'm writing the code, I forgot to put the try after all. So if I don't put the try, I will get an error. Is that true? I see people shaking their head. I hear no. Get a warning. What do you think? Still no. So what does it do? It misbehaves, right? But I know you're not disappointed, because deep down in your heart, you already know this. Never to trust a feature with the word management in its name. Just kidding. So that was not very helpful, isn't it? Because there's no guarantee this will be called. And as a result, we're back to square one. This is like the diesel example I was talking about. I want to be told, don't do this. Here is how you want to do this, right? I want to be able to provide that kind of capability. So what do we do in this particular case? Let's change our plan, change our design just a little bit. So let's go ahead and take that out for a second, back to square one. The first thing, I'm going to make the close method private. If you make the close method private, obviously, you cannot call the close method directly from the outside. That doesn't work. Error. Great. The next step I'm going to take here is to make the constructor itself private. Obviously, you cannot create an object of this class also anymore. That failed. So what gives? How do I really make this work? So I'm going to go back to the resource and say a resource.use as a method. Now, what does the use method do? I'm going to say public. Let's say static void use takes a consumer of resource, we'll say here, and this is going to be a block of code I'm going to pass in here. So I'm going to say import, and let me go ahead and say in this case java.util.function.consumer, bring that in. And now, as you can see in here, we have a use method that takes a consumer. So I can say resource right there and put a little arrow in there. And then I can simply say, here is a resource I want to call into, and simply call the op2 on it and wrap it around. So what we did is to write the use method, which will give us a resource instance back to us as part of this consumer. We can do whatever operation we want to perform. And I don't care about the close. I cannot call it. But then I go back to the use method. And in the use method, I'm going to say resource is equal to new resource. And I put a little try and a finally. I can remember to do this as an author of the class. Because as an author of a class, it's my responsibility for resource cleanup, not a user's responsibility, right? As a provider of a service, I should make it easier for my users to use my instances abstraction without having to do things that would cause more problems. So then, within the finally method, I say resource.close to call the close method. Within the try, obviously, I can say a block.accept. And I can pass to this, of course, the resource we just created. So when you run the code, you can see the resource is allocated. You can see the op1 was called. And then you can see that in this particular case, the close happened automatically. This is not very different from the ARM, automatic resource management, except there is nothing for you to forget. This is the only way the code would work because you're not allowed to create an instance directly. You have to call the use method. It provides you an instance. You can use it the way you want to use it. When you're done, it says, I'll take care of the cleanup for you. So in some languages, they call this the loan pattern. They call it a loan pattern because imagine I go to rent a car. Assuming it's a good rental car company, they clean it up really well before they give it to me. I drive around wherever I want to drive around. And when I return it, They check for damages, usually for me more than others. But they want to verify that this is in a good condition when they take it back. And then they do some operations on it. They may maintain, they may fill gas, they may fill tire pressures, check tire pressure, refill the oil, whatever they need to do. But that's a post-op they need to do. So you can think of applications where you clearly have a pre-op and a post-op. And if you have a pre-op and a post-op, you can isolate this abstract away the pre-op and a post-op into a separate function. And right in the middle of it, you can yield control to a piece of code that can do your domain-specific code or logic. And then when you yield back, it's going to do the rest of the operation. This is a pattern I've used extensively in code in different applications. It removes the burden on the programmers. I don't have to sit there and think about things I would forget. I simply naturally get my resources I want to use, do whatever I want to do with them, and walk away, and the cleaning happens automatically for me. And that's an example of a lone pattern we can benefit from. Now, obviously, in this case, lambdas make it really easy for us to use the lone pattern because the lone pattern gives us the ability, or the execute around method pattern, because it gives us the ability to pass these abstractions around in a very effective manner in the code without we having to struggle a lot. So essentially, you can use this where you need to manage policies in your application. Maybe before a certain piece of code has to be executed, you need to perform some checks, maybe. Well, don't rely on programmers to perform those checks. You automatically do those checks before you yield back to the code. Your code becomes a lot more secure and more manageable as well. That can be really powerful. Like I mentioned, there are so many places I've used this pattern. This is one of my most favorite patterns where I can use functional features and especially Lambda expressions to build applications into it. So to summarize what we talked about, I'm a huge fan of functional programming. I'm a huge fan of Lambda expressions. But I find that there are three things we can enjoy when it comes to design patterns. I do want to emphasize one thing here, though, just to tie this back into things. We all get very fascinated about patterns all the time, and that's perfectly fine. But I'm going to say that overuse of patterns it results in complexity. That's one of the things you want to really keep in mind. So be very suspicious about bringing in patterns. I've had developers say, I want to use this pattern, but they don't really understand why they want to use it. They're just fascinated about using that pattern. Secondly, I would say the more powerful a language is or becomes, the less we will talk about, in general, talk about patterns. So in other words, if a language is more mature, the things we talk about as patterns naturally become language features. For example, if you look at the strategy pattern, you look at this and say, dude, you're passing lambdas around. Yeah, that's the beauty of it, right? You don't have to think about this as a pattern anymore. It becomes a natural way of writing code. So the more powerful a language is, or the more powerful a language becomes, the less we talk about patterns, and those become natural features of a language. You don't go to a colleague and say, I'm using inheritance pattern, right? I'm using polymorphism pattern. They're like, what are you trying to do? This is just common features in languages. You can use inheritance, you can use polymorphism. And I want languages to grow into power where patterns become practices ingrained into languages, so we don't have to really treat them separately. And it's really nice to watch languages like Java grow over time, so some patterns get absorbed into the language, so we don't have to put special efforts. The second is certain patterns where we create a lot of code, where verbose is turning into something really a lot simpler. And the third, some patterns we never experienced before, we can now do so because we can start exploiting some of these lambdas and make it very powerful in what we do. And that's the really fun journey in here. I hope that was useful. Thank you so much.